Welcome to Chapter 9, Lists. Lists are one of the most important and widely used data structures in Python. They allow us to store a collection of items in a single variable, where each item can be of a different type. A list is an ordered sequence of elements enclosed in square brackets and separated by commas. What makes lists special is their flexibility. A single list can hold integers, floats, strings, and even other lists all at the same time. Like strings, list elements are accessed using indices starting from 0. You can create a list in several ways. An empty list uses just two square brackets. A list of numbers, a list of strings, or a mixed list can all be created by placing the elements inside brackets separated by commas. A nested list, which is a list inside a list, is also perfectly valid. Accessing elements works the same as with strings. The first element is at index 0, and negative indices count from the right. For example, index -1 gives the last element. Trying to access an index beyond the list's length raises an index error. The most important difference between lists and strings is that lists are mutable. You can change their contents after creation. Assigning a new value to an index like list1 at index 3 equals black directly modifies the element at that position. This makes lists ideal for data that changes over time. The plus operator concatenates two lists. Joining the list of odd numbers and the list of even numbers gives a combined list. Note that the original lists are not modified. If you want to keep the merged result, you must assign it to a new variable. The asterisk operator repeats a list a given number of times. The in operator checks if an element exists anywhere in the list and returns true or false. The not in operator checks the opposite. These operators make searching and repetition concise and readable. List slicing works exactly like string slicing using start: stop: step. The stop index is excluded. You can extract a portion of a list, skip elements using a step, or create a reversed copy using a step of -1. Slicing always returns a new list. Traversing a list means visiting each element one by one. The simplest way is a for loop that iterates directly over the list. Alternatively, you can loop using range and the length of the list to access elements by index, which is useful when you need to know the position. The append method adds a single element to the very end of a list. The extend method adds all elements from another list one by one. The key difference is that append of a list within brackets creates a nested element, while extend flattens it and adds each item individually. The insert method takes two arguments, an index position and a value. It inserts the value at the given position, shifting all subsequent elements one place to the right. The count method returns how many times a specific value appears in the list. The index method returns the position of the first occurrence of a value. If the value is not found, it raises a value error. The remove method deletes the first occurrence of a specified value from the list. If the value appears multiple times, only the first one is removed. The pop method removes and returns an element. Without an argument, pop removes and returns the last element. With an index argument, it removes and returns the element at that position. The reverse method reverses the list in place, permanently changing the original order. The sort method arranges elements in ascending order by default and modifies the original list directly. Passing reverse equals true sorts in descending order. The built-in sorted function is different. It returns a new sorted list and leaves the original unchanged. Python has several built-in functions that work well with lists. Len returns the count of elements. Max and min find the largest and smallest values. Sum adds all numeric elements together. And the list function converts other sequences like ranges and strings into lists. A nested list is a list that contains other lists as its elements. This is used to represent two-dimensional data, like a matrix or a table. You access an element in a nested list using two indices. The first selects the inner list, and the second selects the element within it. Copying a list requires care. Writing list2 equals list1 does not create an independent copy. Both variables point to the same list in memory. Modifying list2 also modifies list1. To create a true separate copy, use slicing, the list function, or the copy method. When you pass a list to a function, the function receives a reference to the original list, not a copy. This means any changes the function makes to the list are reflected outside the function as well. This is called passing by reference and is different from how integers are passed. The del statement deletes elements from a list. You can delete a single element by index, a range of elements using slicing, or the entire list variable. After del list 1, the variable no longer exists, and accessing it raises a name error. List comprehension provides a concise, readable way to create a new list. The syntax is an expression followed by a for clause and an optional if clause, all inside square brackets. For example, a list of squares can be created as x squared for x in range of 5, which gives 0, 1, 4, 9, and 16. Comparing lists and strings. Strings can only hold characters, while lists can hold any type. Strings are immutable. Lists are mutable. Both support indexing, slicing, and the in operator. But lists have many more built-in methods for adding, removing, and reorganizing data. Finding the maximum value in a list manually requires traversing the entire list and keeping track of the largest value seen so far. Start by assuming the first element is the maximum. Then compare each subsequent element. If a larger one is found, update the maximum. Python's max function does all of this automatically. Linear search is a basic algorithm to find a target value in a list. You check each element one by one from the beginning. If the element matches the target, you return its index. If you reach the end without finding it, you return -1 to indicate it was not found. Double sort is a simple sorting algorithm. It repeatedly compares adjacent elements and swaps them if they are in the wrong order. After each complete pass through the list, the largest unsorted element has moved to its correct final position. The process repeats until no more swaps are needed. Chapter 9 explored Python lists in depth. Lists are ordered, mutable sequences enclosed in square brackets that support indexing, slicing, and all major operations. Key methods include append, extend, insert, remove, pop, sort, and reverse. Lists are one of the most essential tools in any Python programmer's toolkit.